So, colorectal cancer is the second biggest killing cancer, claiming nearly 2.4 thousand lives every single day, with 2 million people being diagnosed with the condition every year. It's been attributed to the bacteria that live within our gut. They live in complex communities like we do, and they can communicate with each other like we do, but they're invisible to the naked eye, and they don't breathe oxygen like we do. They use our intestinal cells as their land, and they fertilize us with energy and nutrients that we need to maintain our health through regulating our immune system, protecting ourselves and them from invasion. However, over time, this system can become saturated because of our diet with chemicals and calories, leading to the production of oxygen, this gas which they can't utilize. So in effect, we begin to actually suffocate the bacteria that we rely on. Now, they're quite robust, so they can adapt to survive in changing conditions. And what they do is they begin to utilize the oxygen present in the environment. Not only do they begin to utilize it, but they start to produce it themselves, trying to convert the ecosystem into one that benefits them. What they don't know is, over time, they start to produce toxic chemicals and more oxygen, which starts to tear down the immune system in place to protect us, and start to seep into our cells, and over time, it will mutate our DNA. Now, what happens when you get mutated DNA alongside an inflamed immune system? Well, that's exactly how cancer starts. Unfortunately, I think we all know the traditional therapies for cancer include chemotherapy, which indiscriminately attacks any fast-growing cell, whether they're cancerous or not, and unfortunately, this leads to massive side effects and pain for the patients. Alternatively, there can be radical surgery to remove the tumour in one foul swoop. However, 60% of all patients who undergo therapy will relapse back to cancer. That's where I get to work in the lab. So I'll identify the bacteria that are promoting our health, the good guys, from the bacteria that are damaging our health, the ones that use oxygen and the ones that produce the toxic chemicals. Now, this can be tricky because the bacteria can lay dormant and inactive, while other communities of bacteria are highly active and contributing to the disease. But I can use novel technologies and methods in the lab to be able to differentiate between the good and the bad guys, hopefully with a view to laying a foundation for a novel bacteria-based therapy in where I generate this profile of beneficial bacteria, culture them up in the lab, transplant them into these cancer patients with a view to actually reducing and potentially reversing the damage done by the bad bacteria, hopefully saving these patients' lives and the NHS a lot of money in the process. Thank you.